In this tutorial, we'll learn about data visualization using plots. Data visualization is the process of turning raw data into graphical representations so that patterns, trends, and insights become easier to understand. We'll explore how different types of plots can help us interpret data more effectively and communicate results in a clear and meaningful way. A line chart is created using Plotly Express by importing the library SPX and then using the pxLine function. In this example, we define a set of x values, 1, 2, 3, 4, 5, and corresponding y values, 10, 15, 13, 17, 20. These values are used to plot points on a graph, and the line chart connects them in order to show how the data changes across the x-axis. The chart is given the title line chart to describe what it represents. Finally, Fig Show is used to display the visualization. A bar chart is created using Plotly Express by importing the library SPX and using the pxBar function. In this example, the x-axis contains categorical values, A, B, C, and the y-axis contains numerical values, 10, 25, 15. Each category is represented by a separate bar, and the height of each bar shows its corresponding value. This makes it easy to compare the values across different categories. The chart is given the title bar chart to describe the visualization, and finally Fig Show is used to display the chart. A scatter plot is created using Plotly Express by importing the library SPX and using the pxScatter function. In this example, we define two lists of values, the x-axis values, 1, 2, 3, 4, 5, and the y-axis values, 5, 3, 6, 7, 2. Each pair of x and y values is represented as a single point on the graph. These points are plotted individually rather than being connected by lines, which makes scatter plots useful for showing relationships or patterns between two variables. In this case, the chart helps us see how the y values change as the x values increase. Some points are higher, such as 4, 7, while others are lower, such as 5, 2, showing variation in the data. The plot is given the title scatter plot to clearly describe the visualization. Finally, Fig Show is used to display the interactive chart, allowing us to visually analyze the distribution and relationship between the variables. In this example, we use the built-in iris dataset provided by Plotly Express, which contains measurements of sepal length, sepal width, petal width, and the species of 3 types of iris flowers. We first load the dataset into a data frame called df. Using pxScatter, we create a scatter plot with sepal width on the x-axis and sepal length on the y-axis. We also use the color parameter to differentiate the species of the flowers, so that each species appears in a different color. This allows us to visually compare the sepal dimensions across different iris species. The plot is given the title iris dataset scatter plot to clearly describe what it represents. Finally, Fig Show is used to render the interactive chart, making it easy to explore relationships and patterns within the dataset. When you run the scatter plot code using the iris dataset, an interactive chart appears in your browser or notebook. Each point on the chart represents a single flower from the dataset, with its position determined by the sepal width, x-axis, and sepal length, y-axis. The points are colored according to the species of the flower, so you can easily distinguish between Setosa, versicolor, and virginica. The chart is fully interactive. When you hover over or click on a circle representing a flower, a small tooltip appears showing detailed information about that flower, including its exact sepal width, sepal length, petal measurements, and species. This interactivity allows you to explore the dataset more deeply than a static chart would. For example, you can see which points belong to each species, identify outliers, and notice patterns such as how some species tend to have larger sepals or cluster in specific regions of the chart. The interactive legend also lets you toggle the visibility of different species, helping you focus on one or two at a time. Overall, this type of plot not only provides a visual summary of the dataset but also enables detailed, point-by-point exploration, making it a powerful tool for understanding relationships and variations within the iris dataset. A histogram is created using Plotly Express by importing the library SPX and using the pxHistogram function. In this example, we define a dataset containing the values 1, 2, 2, 3, 3, 3, 4, 5, 5, 6. These values are passed to the X parameter of the histogram, which automatically groups the data into bins and counts how many times each value, or range of values, appears. The histogram helps us understand the distribution of the dataset by showing how frequently each value occurs. For example, the value 3 appears most often, so its bar will be the tallest in the chart. Values like 1 and 6 appear only once, so their bars will be shorter. This makes it easy to quickly see patterns such as which values are most common and how the data is spread out. The chart is given the title histogram to describe the visualization clearly. When Fig Show is executed, the histogram is displayed interactively, allowing users to visually analyze the frequency distribution of the dataset and better understand its structure. A pie chart is created using Plotly Express by importing the library SPX and using the pxpie function. In this example, we define 3 categories of investment: stock, bond, and saving, which are passed through the names parameter. These categories represent different parts of an investment portfolio. The corresponding values, 30, 50, 20, are passed through the values parameter, which determine the size of each slice in the pie chart. Each slice of the pie represents the proportion of the total investment allocated to each category. For example, bonds take up the largest portion at 50%, making it the biggest slice in the chart, while savings make up the smallest portion at 20%. Stocks fall in between at 30%. This visual representation makes it easy to quickly understand how investments are distributed without needing to read raw numbers. The chart is given the title Investment Distribution to clearly describe what the visualization shows. When Fig Show is executed, an interactive pie chart appears where users can hover over each slice to see exact values and percentages. This interactivity helps in better understanding the composition of the investment portfolio and allows for quick comparison between different categories. In this example, we are creating a style bar chart using Plotly Express, which is a powerful library for building interactive data visualizations in Python. First, we import Plotly Express as PX, which gives us access to simple functions for creating charts without writing complex code. Next, we use the PX bar function to build a bar chart. We define the x-axis values as the months Jan, February, and Mar, and the y-axis values as 10, 20, 15. Each value represents a quantity associated with each month. When the chart is generated, each month is displayed as a separate bar, and the height of each bar reflects its corresponding value. For example, February has the highest value at 20, so its bar appears taller than the others, while March has a slightly lower value of 15. After creating the basic chart, we improve its appearance using the update layout function. This step is important because it allows us to customize the visual style of the chart. Here, we increase the title font size to 24, making the title style chart more clear and visually prominent. A larger title helps viewers immediately understand what the chart represents without confusion. We also apply the Plotly Dark template, which changes the background of the chart to a dark theme. This improves contrast between the bars and the background, making the visualization easier to read and more visually appealing. The dark theme also gives the chart a modern, professional look, which is often used in dashboards and data presentations. Finally, we use Fig Show to display the chart, and this is the step where everything comes together. When this line runs, Plotly renders the visualization and opens it in an interactive output area, such as a Jupyter Notebook cell output, a browser window, or an integrated development environment like VS Code. Unlike static charts, this output is not just an image, it is fully interactive and responsive. Once the chart appears, the user can actively explore it. For example, when you hover your mouse over any bar, a tooltip appears showing detailed information such as the exact month and its corresponding value. This helps you read precise data without needing to guess from the bar height. You can also visually compare values more easily by moving across different bars and observing differences in height and spacing. This tutorial explores the fundamentals of data visualization using Plotly Express in Python. Throughout this lesson, we will learn how to create a variety of charts, including line charts, bar charts, scatter plots, pie charts, and histograms, and how to customize them to make the data more informative and visually appealing. By working with both simple example datasets and real-world datasets like the Iris dataset, we will see how visualizations can reveal patterns, trends, and relationships that might be difficult to spot in raw numbers alone.